In this video, I will explain how to use the parallelogram method to find a resultant vector. So let's jump right into an example. This says, use the parallelogram method to find the magnitude of the resultant vector. So we have two vectors here. Let's say force vector 1 with a magnitude of 5 newtons and force vector 2 with a magnitude of 9 newtons. And the angle between them is 70 degrees. We want to know if we add these two vectors together, what is the magnitude of the resultant vector? So one way to do that is to use the parallelogram method, which says form a parallelogram using these two force vectors. So the first thing we're going to do is draw a line that's parallel to the first force vector. So we'll draw this line right here. Then we'll draw a line that's parallel to this second force vector. So we'll draw this line right here. And what we'll notice is we've just formed a parallelogram. Now, what this method says is that if you draw a line starting from where the two force vectors start at and where they end at, then this line right here, this is your resultant vector. Now, what we'll notice is that we can redraw this as a triangle like this, where this side right here, this is parallel to our original force 1 vector. So this side has, we'll say, 5 newtons as its magnitude, and then this side is the original force 2 vector, so this is 9 newtons. And then we want to know what is this angle right here of this triangle. So what we need to know is that in a parallelogram, adjacent angles are supplementary, which means they add up to 180 degrees. So what that means is in this parallelogram right here, this angle and this angle are supplementary. They must add up to 180 degrees. So if this angle is 70 degrees, this angle must be 110 degrees so that they add up to 180. So this angle is 110 degrees. And now the question is, what is the magnitude of this side of the triangle? Because remember, this is the resultant. This is our resultant vector. So let's label that R. So to find R, one trick we can use is the law of cosines, which says this. If we have a triangle, and let's call this angle A, angle B, and angle C, so we're using capital letters, then the side across from angle C, we'll give it a little c for side C. The side across from angle A is little a, and the side across from angle B is little b. The law of cosine says that if you want to find this value C right here, here's the formula you can use. C squared is equal to A squared, so side A squared, plus side B squared minus 2 times side A times side B times the cosine of angle C, so capital C. And what we'll notice is that we have all the values that we need here to figure out what is this C squared here, which in this case is our resultant vector, which is what we want. So let's go ahead and just fill in all the values that we know. So we'll say C squared is equal to, in our case, A right here, A squared is 5 squared, plus we have B squared, so B in this case is 9, so we have 9 squared, minus 2 times A is 5, times B is 9, times the cosine of angle C. So angle C is 110 degrees. So if we simplify a little bit, we find C squared is equal to 25 plus 81, and this quantity turns out to be negative 30.78. So then if we simplify a little more, we find C squared is equal to all of these values added together. That turns out to be 136.78. And to solve for C, we can take the square root of both sides. And we'll find that C is equal to the square root of 136.78 is 11.695. So that's what C is. And in our case, that's what R is, the resultant vector. And it's the magnitude, so this length right here, of the resultant vector. So the magnitude of the resultant vector is 11.695, and we can say newtons in this case. So that is our final answer. So that's how you can use the parallelogram method to find the magnitude of a resultant vector.